Hey guys, so today we are going to learn about inscribed angles. So, what is an inscribed angle? It's an angle whose vertex is on the circle and whose sides are chords. So, that means that this piece right here, that is my inscribed angle. The important thing to know about this is that the vertex is on the circle. Then if you notice right here, it's cutting off that little piece of arc, right? It's the piece that's the interior of the angle. That is called my intercepted arc. Okay, good deal. So now we have relationships between these arcs and these angles. So how do we know what the measures of these angles are? So our angle is going to be equal to our arc divided by 2. All right? So if this arc is 50, that means that this angle is 25. Or another way to think about it is your arc is equal to 2 times your angle. So if your angle is 25, then your arc is 50. Now, that's still going to be true. This might seem a little bit strange, but let me show you what's going on here. So if you notice, here's that purple angle, right? And it intercepts arc AC. Then there is this angle too. It also intercepts arc AC. So since angle 1 and angle 2 both intercept the same arc, that means that they're congruent. So angle 1 intercepts AC, and angle 2 intercepts AC. So since they're both half the measure of AC, that means that angle 1 is congruent to angle 2. So if we have two angles that intercept the same arc, then that means that they're congruent. Cool. Now let's go and find some values. So we know that a whole circle is 360 degrees, right? So what I'm going to do is I'm going to take 360 minus 130 minus 156 to get just this part of my circle. And when I subtract that out, I end up with 74 degrees. Now to actually find x, I have to take that arc and divide it by 2. So 74 divided by 2 leaves me with 37 degrees for x. All right. Now in that next one, we can see that right here, we have our central angle is 102, right? What you might remember is that our central angle is equal to our arc. So since that central angle is 102, that means that this arc is also 102. So then to find x, we have to take our arc and divide it by 2. So that will leave us with 51 degrees. Okay, so we can see that this line right here passes through the center. So that means that it's a diameter. So that means that from here to here is 180 degrees. So to find x, I'm going to take 180 minus 130 minus 30. So that leaves me with x being 20 right here. So down here I'm going to put x equals 20 degrees. Now, y right here, that angle is intercepting that arc that's 30 degrees. So I'll have to take him and divide him by 2, so y equals 15 degrees. Then I'll do the same thing over here. Angle z is intercepting the arc that's 20 degrees, so I'll have to take that 20 degrees and divide it by 2. So z equals 10 degrees. Okay, now we have a triangle kind of going on in there, but here's my advice. Only look at bits and pieces at a time. So right now, I am only going to look at this blue angle that has the 75 degrees in there. Now, I know I have to multiply that angle by 2 to get this arc over there. So 75 times 2 is 150. So now I know x is 150 degrees. All right. Now let's take a look at this 35-degree angle. We're only going to look at that guy. So remember, I have to take my angle and then multiply it by 2 to find that arc. So 35 times 2 gives me this guy as 70 degrees. So y equals 70 degrees. Now we need to figure out z. So we know that the entire circle is 360 degrees. So I'll take 360 minus 150 minus 70. And that will leave us with 140 for that arc right there. So that means that z equals 140. Good deal. So here's what we know. If we double our angle, it'll be equal to our arc. Now, we don't have just plain old numbers, we have these algebraic expressions now, but that relationship is still true. I want to take 2 times my angle and set it equal to my arc. So 2 times what I have in there for my angle is 7x minus 8. And what I have for my arc there is 12x plus 12. That is plus, just making sure. All right, so now we'll go through and solve. First thing is I'm going to distribute that 12 out, or the 2 out. So I have 14x minus 16 equals 12x plus 12. Now I'll subtract 12x from both sides. So I have 2x minus 16 equals 12. Now I'll add 16 to both sides. So 2x equals 28. Then we'll divide by 2. So x equals 14. All right. Now this next one might look a little bit goofy, but actually it's easy. Don't be afraid. So as you might notice, I'm going to put this 50-degree angle in a different color there. There we go. So this purple angle cuts off this curly Q arc, and so does my blue angle. So since both of those angles intercept the same arc, that means that they're congruent. So that means that x equals 50. All right. Over here. Once again, these two angles, they intercept the same arc right here. So since they intercept the same arc, that means that they're congruent. What do we do with things that are congruent? We set them equal to each other. So I'm going to set 5x minus 81 equal to 2x. So I want to get all of my x's onto one side, so I'm going to subtract 5x. So negative 81 equals negative 3x. Then we'll divide by negative 3 on both sides, so x equals 27. All right, Here we go. So let's say that we have an angle that is, oh, excuse me, an angle that is inscribed inside of a semicircle, which basically means, hey, I have this angle right here, and the sides of these angles are going to go out at the ends of the diameter. All right? So we know that if it goes out at the ends of the diameter, then this is 180 degrees, right? I'm going to write diameter there real quick. Okay, cool. So we know this is 180 degrees since it is a semicircle. So I have to take that and divide it by 2 to get the measure of angle C. 180 divided by 2 is 90. So really, we have a right angle right there whenever we have right angle, whenever it is inscribed in a semicircle. So now we're going to have a bunch of right triangles, so that's going to be really helpful for us. All right, so we see that this is an angle or a triangle inscribed in a semicircle. So that means that this angle right here has to be my right angle. So I know y equals 90. Now we need to solve for x. So we know that all the angles of a triangle add up to 180. So I have 90 for that first angle, x for one of my other angles, and 2x for my last angle. And that will equal 180. The next thing we need to do is combine like terms. So I have a 1x and a 2x, and when I combine them, that makes a 3x. So now we'll subtract 90 from both sides. So then 3x equals 90. We'll divide both sides by 3, so x equals 30. Good deal. Now this next one looks scary because look, here is a one angle and it's inscribed in a semicircle. Here's another angle and he is also inscribed in a semicircle, and so is that angle x. Now each of those angles is inscribed in a semicircle, and we know that each of those has to be 90. So x, y, and z are all equal to 90. Okay, one last thing to learn about inscribed angles. So there's not only triangles that get inscribed inside of circles, sometimes we have quadrilaterals that get inscribed inside of circles. Now when we have a quadrilateral that's inscribed inside of a circle, opposite angles are supplementary. So what does that mean? Remember, opposite means across from. So that would mean that angle 1 and angle 3 would add together to equal 180 degrees since they're supplementary. The other two angles are also supplementary. So angle 2 plus his opposite angle, angle 4, is equal to 180. All right, let's solve these guys down here. So remember, opposite means across from. So x and 77 are going to be supplementary. So x plus 77 equals 180. We'll subtract 77 from both sides, so x equals 103. All right, now this way, y and 60 are supplementary. So y plus 60 equals 180. Then to solve for y, we'll subtract by 60 on both sides. So y equals 120. Okay, it still works the same way in this guy over here. 80 and x are opposite from each other. So that means that they are supplementary, so they add to 180. So x plus 80 equals 180. So x equals 100. Okay. Now we know that 75 and y are opposite of each other. So that means that they too are supplementary and add up to be 180 degrees. So y plus 75 equals 180. Subtract 75 on both sides. So y equals 105. But now we've got that z kind of floating out there in space, right? Well, right here we have this 80-degree angle. Now, if we take 80 and we multiply it by 2, then we would know that from here to here is 160 degrees. Now, I know this part of that 160-degree arc is 50. So that means that there's 110 left over for z. So that means that z equals 110. Doggy just got in from playing outside. She's happy. Okay, last one. All right, so opposite angles are supplementary. So 21x minus 4 plus 79 equals 180. So the first thing we want to do is combine like terms. So I have 79 minus 4. Sorry, she's getting water. She's a pupper. Okay. Plus 75 equals 180. Then we'll subtract by 75 on both sides. So 21x equals 105. Then we'll take 105 and divide by 21, and x equals 5. Oh, it's a little hard to see down there. Okay, so I will see you guys a little bit later, and we'll talk about more angles and circles. Bye. Love you.